Hello, I'd like to talk to you about structure and properties of water in this video. The structure of water. So this is one molecule on the left-hand side of the screen. As you can see, it's got one oxygen atom and two hydrogen atoms. Each of the hydrogen atoms are bonded to the oxygen. Do you remember what type of bond that is called that happens in this location right here between the hydrogen and oxygen? We've talked about that previously, and we'll talk about that in the next slide. So in a single drop of rainwater, there's millions of molecules of water. So millions of molecules of water make up one raindrop. That's a lot of molecules. So the structure of water, we talked about the other day, this sharing of these two electrons between the oxygen and the hydrogen is called a covalent bond. This creates a chemical that can be represented by a chemical formula. Please make sure you understand this is a formula, not an equation. Equations have pluses and minuses in them, and as you can see, there's no pluses or minuses in this. Please make sure you write the chemical formula of water as H2O with a subscript 2. This implies that there's two hydrogen atoms and one oxygen atom. So water is a polar molecule. It's a molecule that has electrically charged areas. So if we look at this water molecule, you can see that the hydrogen is partially positive. That's what this symbol means. It's kind of an open-ended infinity symbol. So it means it has a partial positive on this side and this side, and we have a partial negative on the oxygen side. The reason why is because oxygen loves electrons, and those electrons spend most of their time around the oxygen atom. They are shared with the hydrogen, but they spend less time there. That makes this molecule polar. Because water is a polar molecule, the positive hydrogen of one molecule of water is attracted to the negative oxygen of another water molecule. So this hydrogen in this molecule is attracted to the oxygen in this other molecule. We represent this by a dashed line like you see here. Do you remember what that type of attraction is called? See if you can remember. That attraction is called a hydrogen bond. That's the attraction between two separate but oppositely charged parts of different molecules. So we also have something that's called hydrophilic. Hydrophilic means water-loving or water lover. This describes substances that are chemically attracted to and dissolve in water. So you can see here we've got this giant molecule. This is a molecule of glucose, and it's got positives and negatives all around it. All of these are partial charges because of an unequal sharing of electrons. Now, because there are all these partial positives and partial negatives all over the place, this molecule actually dissolves in water. When you add up all these positives and all these negatives, you'll notice that this molecule as a whole has no charge, but parts of it are partially positive and partially negative. So all substances that dissolve in water are hydrophobic, including polar molecules such as glucose, and particles with positive or negative charges such as sodium and chloride. So if you take table salt and put it in water, you end up with sodium ions that are charged and chloride ions that are also charged. That's why salt dissolves in water. It is hydrophobic. Just remember the term like dissolves like. So if something is polar, water is polar, therefore it will dissolve in water. Anything that's polar is hydrophilic, water-loving, will dissolve in water because water is also polar. Nonpolar substances. Nonpolar substances have no charges on any ends. They do not have charged ends. Therefore, they don't dissolve in water. You can think of it as water has this positive and negative side. It can grab a hold of something else that has a positive or negative side, But if something else does not have a positive or negative side, water can't get a hold of it. So remember that like dissolves like. Polar dissolves polar. Polar water does not dissolve non-polar substances. So you can probably think about things that are non-polar. Think about things that don't dissolve in water, such as, fats, oils, and waxes don't dissolve in water. These molecules are called hydrophobic. They're water-fearing. This describes substances that are insoluble in water. In other words, they do not dissolve in water. Molecules are hydrophobic if they do not have partial negative or partial positive charges, and if they are non-polar. So all lipids, which are all categories of fats, oils, and waxes, are hydrophobic. They don't dissolve in water. As you can see here, we've got a layer of oil on top of a layer of water. We could shake this all day long, and these will never mix. Because remember, hydrophobic molecules dissolve other non-polar molecules. But remember, like dissolves like. So non-polar will dissolve non-polar, but polar will not dissolve non-polar, and water is polar. So now that you know a little bit about the properties of water, let's see if we can address this. What kind of bears dissolve in water? I'll give you just a minute to think about this. And if you want to pause and think about it, pause now, because here's the answer. Polar bears, right? The water is polar, therefore polar bears would dissolve in water. Kind of a silly joke, but now that you understand water and that it's polar, you understand the joke. Have a great day.